Hey guys, making another video today on using FOMO, the script that makes that emulates Wemo devices on your network, so that you can control them via Alexa or in scripts. Um, so the original FOMO script was written by MakerMusings, makermusings.com. I forked the repo, I've done some changes to it. So this is kind of a walkthrough of those changes and how you can use them to control your own devices or emulate your own devices. Use the Raspberry Pi to control other stuff, and that way you can control it with Alexa. Um, so without any further ado, let's jump into it. So we're going to jump onto the GitHub repository where this code is so far. This is FOMO, apptour.com/FOMO on GitHub. This is the original. Branch master is the original version that I forked from Maker Musings. So if you've watched my other videos and taken a look at this, this should be familiar. I've pushed up a refactor branch to this, and you can clone and check it out. So the README has a refactored version. I've started writing a README here. It's not complete yet, but I'll continue to work on it. So once you clone it and download it, you will get something like this when you check out the refactor branch locally. And some of the things that you might notice is there's no longer a fomo.py script like there is on the master branch here. All the code was in this one file before, and what I have done is broken it out and made it its own module. So right now, these are the files that separate classes out that were all in the main file. So if you jump here, like these are the files that are here. This is the init. Basically, this says that this module is composed of all these files, and these file names are within this directory here. fomo.py is here now, but it's a lot smaller than it was originally, and you'll notice that we import these classes, which are new definitions that I've added. It's broken down. I'm going to add more comments to this so that you can understand what it is, what it's doing. I've broken it down even more, so like this condenses the response before it was quite a bit longer. This class here is largely unchanged from how it was originally defined. This one is the handler. So in the original script, now near the bottom, you may recognize this. This is a dummy device. So if you emulate a dummy device by adding it in the main.py, which is this file right here, then, so this is the file that you're going to run instead of running fomo.py. So in here you'll recognize some of this here. This was down at the bottom of the original FOMO handler. And these are the original REST devices that were defined in MakerMusings version of the script. These are some dummy devices. So these two just log on and off to the console when you call them. And I've explicitly defined a port number here for it to listen on. This one here does not. You can add it if you want to. This is another one that I added. It uses a file handler, which basically runs a script, which is this one right here. That's what I have it set up. So fetch news is you put it in the main directory here if you want to write your own script and have it run this script. When you tell Alexa to turn on Twitter trends, then it should call and execute this script. I'll walk through what that does here in a minute. Let's see here. These are GPIO devices, so if you execute on the Raspberry Pi and you want to switch pins on and off, then you can use something like this. You can specify the port number as well, which I would suggest explicitly specifying a port. Just make sure it's not one that's already in use by some other well-known service. And then that way, every time you launch it, it'll be on the same port. So if you run the script with the D flag, then it will log to the console, which is what we want it to do. And then the rest of this is stuff that was already here. when you if you downloaded the original script. Also, I have this commented out now because I'm running this one on the Mac, and the Mac does not have GPIO. So this is commented, as well as the import right here. If you are running this on a Raspberry Pi, you'll want to uncomment that, as well as in FM device. Oh wait, maybe not, it's not the one. It's not FM device, it's FM handler. You'll also want to uncomment this import, and then this handler here. So if you uncomment that, then you have access to that on the Raspberry Pi, and you can switch the pins on and off with Alexa. The FM polar, this is basically exactly the same as how it was defined previously. I just moved it into its own file. FM responder, it's this broadcast responder. That's pretty much the same, I believe. I don't think I changed much there. I might have done a little bit. Utilities is a new class that I added, and I moved the debug basically into its own file. XML is another file that I added. I moved the setup XML into here, which I'm gonna refactor this a bit and move this into its own standalone XML file, and then we'll just load that where we need it. And then these are helper methods for logging out or accessing XML fields from a file. WeMost request is a new class that I added, and its purpose is basically in the FOMO.py. This one is the one I refactored. Instead of having this huge function, I broke this down and shortened it up, and it uses it here. It breaks it down, it takes the data that we get from the socket listener, and then it parses it into this WeMost request. And so you'll see here HTTP parser, and it parses it out, it checks to see if it's a SOAP action, and if it is, then it sets the name as the action that's going to be run. Here we parse out the command, whether it's a 1 or a 0, and then we have these helper functions, which helps us define or let us know if it's requesting the setup file or if it's actually trying to run a command. These are just some helper functions here, and then an init function. And the fetch news script, this is a demo one, so you can look through it and see if you want to run a script, if you want to call Alexa and have it run a script and perform an action, and not actually switch a device on and off, and it's a fire and forget, and you want to have it on your Raspberry Pi instead of like host it on a web server and use a Alexa skill or something like that, then this is just an example of how you could do that. So this one I have a URL for the trending Twitter topics, and then I just set a user agent, which basically says, hey, this is a Firefox browser, even though it's not, so it doesn't say it's Python. The request will fire off, we'll pass in the request headers, we will make the request, we'll get the response, then we are going to get the credential file, which I have a demo version here. So in the parent directory, you can have a cred.json, which is a sibling of the FOMO directory. So when you clone it, it will be here, and you put the credential here. This is credentials for the email address that I'm using for this, but I obviously don't want to share that on this video, so I have a demo credential here that you can look at. This is what your JSON file should look like. You have the sender, so you put whatever email you want to use to send, and this is set up to be a Gmail address because we're using the Gmail SMTP server. So put a Gmail address here and the password, whatever your password is for that. Whatever the password is for that sender email address, you'll put here. And then the recipient is the email address that you want to send it to. And then in this script here, basically what we're doing is we're looking for this file, the credential file. We're saying find the file path for this file that's being run, which is fetch news, and then we are going to go up one directory and we're going to look for cred.json. Once we have that, we'll open the file, we'll read the JSON, and then we will try to get the from address, the from password, and the to address with these three keys, which correspond to sender, credential, and recipient. Once we have those, this basically bails if any of them are not set. We will construct the message. This is going to be a multi-part message. Set the from field, the to, the subject, attach our page as HTML. Since basically it's an HTML page, you could point this to something else because the HTML doesn't render that well in Gmail. And then you'll set up your SMTP instance. This is the hello call. This is start TTLS or start TLS. Then you will log in with your sender email address, and then you will try to send this. And then once it's sent, you'll quit. And these basically just catch exceptions. So this is the script that we run from the main.py when you call Twitter trends. We've defined it to run on this script. On this port. And that's pretty much the changes to this. I have this installed on a Raspberry Pi at the moment, which I am logged into via VNC. And I have it running on the local address. So when you clone on the Raspberry Pi, you will you can clone this repo, and then you will uncomment the fields that I said in the script if you want to access the pins on the Raspberry Pi. If you just want to run this to make sure it works, you'll need to install HTTP parser, which is stated here. You can run sudo pip install HTTP parser. That will install it on the Raspberry Pi. Then you can run this script by calling main.py/d, which will allow these log statements to show up. So right now we have 3 devices registered because those are the 3 that I have uncommented: Office Lights, Kitchen Lights, and Twitter Trends. This is the IP address for this Raspberry Pi on my internal network, and these are the port numbers that they're listening on the end here. So I have this other script, activate.py, which, let's see here, we'll open that up. You'll find it in the tests folder here, activate.py. You can run this on the Mac or something else. This specifies the host. So this is the one we want to call it on is, so this host right now is on the Mac. This one is on the Pi. I have modified this activate.py on my Raspberry Pi to point to 15 because that's the IP for this. The IP for my Mac is 11, which is why I have it set here at 11. So update this to whatever your IP address is on your local network. Yours, unless you have multiple routers, which I do, yours will probably be the 192.168, 1 dot something. And then these port numbers, you want to match whatever you have set up here in your main.py. And this is just for testing. This basically sets up the body that will be sent to the Raspberry Pi when you run this script. These are the headers that will be sent with the request. This is turning it on, this one right here. If you change that to a 0, then it should change it to off. And then you'll send the response here, or request, and this will run on your Pi. So we'll give it a try here. I've got it running here. This is main.py. I've got it running, and then in this separate window here, we'll go ahead and try to run activate.py, and you'll see that the Raspberry Pi has responded to a request 1 for Office Lights, which is this here. If you change that to 0, then it will say responding to 0 for office lights, and it'll be off. And since activate.py, we are specifically requesting the office port here, and that's why it's doing office lights. If we change it to 52582 or 52583, then it will send the email. So let's give that a try. So what we want to do is open up activate.py. And we will change this port to be the kitchen port. And we will save, close this script, run this script, and you should see this say kitchen light on here. See, responding to 1 for kitchen lights. So now, I think what we can try to do, I will plug in my Alexa and see if we can't get it to turn it on and off when we talk to Alexa. It should be emulated as a device on the network. So I just plugged in my Alexa. I'm waiting for it to boot up. Alexa, discover devices.
Starting discovery. This will take up to 20 seconds. If you haven't already, please enable the smart home skill for your smart device from the Alexa app.
So you can see that it returned the setup here.
I found one new plug called Twitter Trends. To control it, say, turn off Twitter Trends.
Alright, so it discovered the new one. These two I had previously. So we'll see what happens when I call those two. Alexa, turn on office lights.
Okay.
Alexa, turn off office lights.
Okay.
Alexa, turn on kitchen lights.
Okay.
Alexa, turn off kitchen lights.
Okay.
So you can see that that's working. I'm going to try the Twitter trends here in just a minute, but I'm going to log into my account where I have the email going, and then I will come back. Okay, so I am logged into the account where the email will be going, which is this tedbarron@gmail. It's just a test account that I use just for stuff like this. Nothing personal in it. Anyway, and I have set up my credential file with the password in here, and it is in the document share, which is the parent directory of the FOMO files. So when I ask for the Twitter update, I should see it there. This is what that credential file format looks like. This is not my actual credentials. And let me see here, I have it set up as Twitter trends. So what I will do is ask for the trends and see if it shows up in my email account. So Alexa, turn on Twitter trends.
Okay.
And there you go. It showed up in my email. This is just fetching the JSON for that URL in the script. So whatever is there will show up here. It's all HTML. So there you go. This could probably be rendered better, but that's how you can hit a web page and forward the email based off of a request to Alexa. So that'll do it for now. Like, subscribe. If you want to see more, leave comments and let me know what you'd like to know. Keep an eye on that GitHub repository, as I will be pushing up changes to it. When I'm done, I will version it, and you'll be able to see it in the master branch on appteur, appteur /FOMO, FAUXMO. Thanks.